Okay, in this video, we are going to actually see how can we work with images, particularly how can we read the image, how can we view its channels, how can we play with the different subregions of the image. So let's start by importing certain necessary packages. Import NumPy as NP, because most of the packages, when they read the image, they report the image as a NumPy array or NumPy matrix or array. So then import matplotlib.pyplot as plt. That's one package for reading and writing images, although there are several others like Pillow and OpenCV and stuff like so. And for now, let's import these packages and let's read an image. So next we read an image. Let's say we have an image somewhere here. That's the image of a bird. So let's copy its path. Control C. Let's go back to our Jupyter notebook. So we have now im equals im plt, im read r, and that's the path of the image, and that's the image we have. Now if we basically now we have this image available with us. Let's just show this image plt.imshow. That's a function in matplotlib.pyplot and it should display the image in the notebook. Yeah. So this is the image. That's an RGB image. One strange thing about this particular image is it has 4 channels rather than 3 channels. Rather than having 3 channels like R channel, green channel, and blue channel, it has 4 channels. The 4th channel is not informative for us, so let's get rid of this 4th channel and let's just have the 3 channels with us. Let's say im2 equals im, and just pick the only 3 channels, and now just display the shape of the image, and that is 1440 by 2560 by 3, where the very first channel is red, then green, and then blue. These are the channels. So what if I just draw for example, what if I change the intensity at the red channel? So for example, let me pick the red channel as im2. That's the red channel. This is the red channel. And let's say we have green channel as im2. That's green channel. And similarly, we have blue channel, red, green, and blue, im2. And this is 2. These are different channels. If you see all these channels, for example, each channel looks like a grayscale image. And even if you plot each channel individually, imshow r c map as color map as gray, then it will look like to you this particular, for example, this particular type. You can plot the 3 channels individually as well. So for example, if you just say okay, fig ax1, ax2, ax3 equals plt.subplots. Subplots, how many are these? Let's say 3 by 1. And fig size, you fix the fig size as 10 by 15, let's say. And then what you do is ax1.imshow r, where cmap is gray, and then you have ax2 as into imshow rg, cmap is equal to gray, and then you might have third one, which is the blue channel, imshow blue channel cmap equals gray. And here let's plot them horizontally, so let's make it 1 by 3. So with this, oh, fig size, I always miss this. Yeah, equal to. So with this, you can now see that's the red channel, and that's the green channel, and that's the blue channel. So now from these red, green, and blue channels, you can see that the original image has more contribution at several places for red channel, because the red channel is more bright, and then we have green channel, and blue channel has pretty small values. We can see that in the image as well. The image is more reddish than the rest of the colors. Let's change the blue color. Let's increase the blue color and see what the image looks like. So for example, let's say im3 is im2 dot copy. Let's copy this image. And then what we do is we change the blue channel and make it maximum. So let's make it maximum, the blue channel. So with that, now if we display im3, it will be more bluish. So let's see, plt.imshow im3. So you can now see the image becomes more bluish. Yeah. So similarly, we can change the different areas of a particular image. For example, let's say im3 is again im2 dot copy. So what we do is we go to im3 and at a for example location from 100 to 600, let's go to this position, and again from 100 to 600, and in this particular position, in the red channel, we make the red channel as pretty small. The red channel becomes pretty small, and for the same bounding box or rectangle, or in this particular case it's a square, let's make the green channel a bit higher. Let's say this one. And for the same kind of rectangle, let's make the blue channel also a little bit smaller. So let's see, let's say 20. And then let's display the image, plt dot imshow im3. So what should happen is at this particular bounding box, there should be a fixed color that is defined by this red contribution, this green contribution, and this blue contribution. Whatever this mixture, whatever color that mixture brings to. So let's see. In this particular case, oh, it shouldn't be white. It shouldn't be white. I guess something has gone wrong. It shouldn't be white. Let's do it for, let's say, let's make it completely red. Let's make it red. Yeah, it is red. Similarly, if we want to make it green, it will become green. If we, for example, do this thing, red, much more red, and then about some contribution about this blue, then we might get something like this. So that's a different kind of color. Wow. Similarly, we can play with these kind of colors. For example, if we set this one as 10, then maybe this becomes further different color. Oh, it becomes white. It has some problem with this green color. Maybe I should set this green color as maximum. Maybe that's particularly a problem with this particular image, although it shouldn't be a problem. Oh, that's more greenish. Yeah. So yeah, you can play with different channels. You can set different colors of different channels for different kind of images, no problem. In the next video, we will see how to convert an image to a grayscale image. And we will also see how we can write our own function to actually convert an image to a grayscale image. And then we will see some functions from built-in libraries that can do that stuff for us. So hope to see you in the next video.